Hi everyone, and welcome to electricity lesson number 2 on current electricity. So we're going to have a warm-up first, and we're going to compare static electricity, which was the topic of our last lesson, and we're just going to compare and see how it's different than current electricity, which we're going to learn about today. So today's lesson is lesson number 20 on your handouts, and it begins on page 121. Okay, and so the learning goals of today's lesson, so at the end of this lesson, you will understand what makes current electricity, what is a battery, and you're also going to understand the symbols for electrical circuits. So after you've done after you've kind of listened in on the lesson, maybe you do a little bit of the handouts if you've gotten them in the mail now. After that, and you practice a little bit, I want you to click on the globe on the PDF lesson or the PDF attachment, and it will give you a direct link to the quizz's assignment. And please remember to sign in with your TDSB account. If you sign in with your TDSB account, email account, your results from the quizzes assignment on current electricity will automatically be updated on Google Classroom, and then I can give you your marks there. Remember also that you can do the assignment multiple times until you feel comfortable. Okay, let's do the warm-up. So static versus current electricity. So if you remember, static electricity is, for example, when you rub a balloon against your hair, okay, it makes things attract or repel, okay? So it'll make things attract or repel. So here, after you rub a balloon on your hair, it will actually pick up little pieces of paper, for example, because charged objects like a balloon will pick up a neutral object, or opposites attract, for example. Okay, now current electricity is different. Okay, so current electricity is where electrons actually move around and they flow on a circuit. Okay, so like something that's connected. So in current electricity, there's a source of energy that moves around in a circuit, and it flows along a circuit, and it can actually supply power for appliances. Okay, so for example, we've connected a light bulb with the wires to a battery. So there's a light bulb connected to the battery. And then what happens? There's like a power conversion, okay, an energy conversion, and it actually powers up this light bulb. Okay, so usually static electricity, it's not the most useful type of electricity, let's just say. Okay, it's not good for, powering your appliances. Okay, so static electricity, not the most useful, but current electricity is very, very useful. Okay, and let's just complete this warm-up by thinking about whether or not these items will cause static electricity. So I'm just going to put a big S here, or if it will cause current electricity. Okay, so I want you just to take a look at these items. So we've got a balloon, we've got an electrical cord, we've got a battery, and we have a comb that's run through long hair. Okay, so for these 4 items, just think to yourself if it's going to be static electricity that's produced or if there's current electricity. Okay, so is it going to be static electricity or current electricity that's going to be produced? Okay, so pause the video, think about it, and then come back to me. Okay, I hope you were able to figure that out. And so I'm going to take up the answers right now. Okay, so a balloon rubbed against a rug, that's going to be static electricity. Okay, so is a comb running through long hair, whereas a battery and an electrical cord are both current electricity. Okay, so I hope you can kind of see the difference as we go into our lesson. Okay, so here we have, for example, an electrical meter. So you might see these on the outside of a building or even on the outside of the house, okay? It tracks the amount of electricity you use. And then right over here, this is probably a voltmeter or a multimeter that is determining how much voltage or power, let's just say, is coming from these voltage is coming from the electrical outlet. Okay, here are some key terms. I'm not going to go into them. Let's just see it in the actual lesson. Okay, so let's turn to page 122. Okay, think of all the ways you use electricity each day. You wake up to an alarm clock or a radio. Okay, so when we wake up to our alarm clock, I think a lot of us have now cell phones, right? And so our cell phones have a battery in them, and the way we charge them up is to plug them into the wall. Okay, so that uses current, electricity current. Okay, you might turn on an electric light, or you might use an electric toothbrush, or you make toast. You watch television, you listen to records, you use air conditioners. Just think about lights. Almost every place you go to, you find electrical lighting. About 100 years ago, there was no electricity in homes, schools, factories, and offices. Try to imagine your life without electricity. The electricity that works all your electrical appliances is called electric current. This is a flow of electrons. Okay, so electrons flow in a path, okay, and then it actually creates the current electricity. Electrons are the parts of the atoms that have a negative charge. There is another part of the atom that has a positive charge. Electrons move along a path called a circuit. So everyone say circuit. While the electrons are moving, the circuit is complete. Okay, so if electrons are moving, then the circuit is complete. So let's just take that down as a quick little note. Okay, so please take that down. If the electrons are moving, it means that the circuit is complete. If the electrons stop moving, the circuit is incomplete and the electricity stops. Okay, let's take that as a little quick note, just because that's like the main point of this lesson. Okay, so take a moment and just copy this down. So when a circuit is complete, that means that there is electricity flowing through the circuit. When it is not moving, so when electrons are not moving, it means that the circuit is incomplete and there is no electricity. Okay, so just think about, for example, a light switch. Okay, when we turn it on, it means that the circuit is complete. That means that electrons are moving, and then that means that there is electricity. If it is not moving, that means that, for example, if you want to make a circuit incomplete, you can flick the switch off. Then electrons don't move, and then there's no electricity flowing through the light bulb, and then your lights won't turn on. Okay, so let's keep reading. Some of our electricity comes from batteries. Electrons move from the minus or negative terminal of a battery to the positive terminal or plus terminal. Okay, so I'm gonna let's take a note for that one as well. Okay, so just take this down. Electrons move from the negative or minus to the plus terminal. Small batteries like those used for flashlights are called dry cells. So we use batteries or dry cells for small portable devices, but most of our electricity comes from machines called generators. So everyone say generators. Okay, so generators, for example, Niagara Falls has huge water wheels, okay, that turn around, and then by turning them around, it actually generates electricity using magnets and coiled wires and that sort of thing. And we might learn about generators later on, okay? So those generators are what powers our power grids, okay? If you think of a nuclear generator, they boil water by heating it up using nuclear materials, and then the water heats up, and then it turns some turbines, and then those are by turning those turbines, it actually generates electricity. Okay, each year the world uses more and more electricity. More and more generators are needed. Okay, so we can use batteries for smaller devices like our phones, and then we can recharge them. But ultimately, we need generators to generate a lot of electricity. Okay. Okay, so here are some common electrical symbols. These are important. We're going to be learning about these, and you are also going to have to kind of like memorize them, or actually, maybe you don't need to memorize them right now. As you're doing your assignment online, what I want you to do is you can have this available even, okay? Okay, so for example, if we have a wire, so I'm just going to, a wire, you just draw it like this, okay? Now, a light bulb, just in case you don't know how to draw it, okay, I find that it's easiest if you do like a cursive letter E, and then you just put a circle around it. Okay, so I'm just doing like, not really alternative, but I just want everyone to practice drawing these, okay? Next up, a dry cell is also called a battery, okay? And so what you have is a long and then a short line, and then the wires right here. These are the wires at the left and at the right here, okay? Now, the long part is called the positive terminal, and then the short part is the negative terminal, okay? So if you kind of have seen, batteries before, you'll notice that they often have a little nub, okay? So the nub is actually the positive part of the terminal, and then the flat part of your battery, like an AA battery or a triple A battery, okay? The bottom part here that's flat, that is the negative terminal, okay? Over here, again, since this is the long part, this is going to be the positive side. This is the negative side, okay? So how do you draw this? Sorry. Uh, Sorry, I'm just going to shift things over a little bit, okay? But how do you draw this one here? It would be, you go long, short, that represents one battery. And then if you have another long and short, it's like the positive, negative terminal of a battery. That represents two batteries that are connected together. Okay, so sometimes a toy or a device will require two batteries. In a schematic diagram, like on the blueprints, let's just say, of electrical appliances, if let's say you're a toy manufacturer and you're making a toy, you would have a schematic drawing and it would have two batteries in them. Okay, so this is two batteries. So please copy this down if you have the paper. Okay, next up, this is called a resistor. A resistor represents anything that slows down the electricity. Okay, so this can be if the electricity is used up, or if just in general, sometimes things get slowed down just by having a different type of material even. Okay, and so you just kind of make a zigzaggy line. It almost looks like a heartbeat monitor. That's what I think of it as, okay? And this is called a resistance for an appliance, okay? Don't worry so much about this, okay? We won't focus on this so much. Okay, next up, we do want to know this. This is just like a light switch, okay? So how do I draw them? I don't usually do them with the flags. I would actually just draw them as this, okay? So just do a circle and then put like a gate and then another circle, okay? And this just shows that the gate is open, okay? Now, when it is open, and I want you to copy this down, when the gate is open, this actually means that the device is off or the circuit is off, and it is also incomplete. Okay, please copy this down. Incomplete. Let me type that out for you. Sorry, because I know a lot of you don't like it when my writing gets messy. Okay, so an open switch is actually off. So you just have to be careful because I think sometimes students make a mistake because when you think of something that's open, you might think that it's on, right? Like if a store is open, it means that it's like, you can actually go into the store and it's open, right? And we also, like when we were younger, we would say, for example, open the lights rather than saying turn on the lights when we were less mature and we didn't know how to say things properly. And so when we say open the lights, you think that the lights are on then, right? But technically, if the switch is open, this actually means that the metal is not making contact with metal, and then the electricity cannot flow, okay? So it has to be a complete path in order for electricity to flow, okay? And I'll show you a picture of that in a few moments, okay? So when the switch is open, so let's underline open, so off. If it's open, it means it's off. And if it's off, it means it's incomplete. Okay. Now a closed switch, please draw this as well. Okay. We would just draw these two dots just to just to like show that there's actually a switch in there. Okay, so that means that metal is making contact with metal, the wire is making contact with the wire, and it is closed. Okay, so when the switch is closed, it means it's on. So on means closed. And this means that it is complete, and that also means that the electricity is flowing. Okay, so there's quite a bit of like layers right here. Okay, so if I say that something is complete, it means that the switch is closed, and then if the switch is closed, it means it's on. So all of these things, these three things are kind of like meaning the same thing. Okay, so there's a few layers here. You might have to jump around a little bit in order to understand, not jump around, but like make a few connections, because these are like all synonyms. They all mean the same thing. When the switch is closed, it means it's on. When it's on, it means it's complete. Or if you see a picture where everything is making contact, it means that the electricity is flowing. Okay, the last thing is, for example, a motor. Okay, so let's just say you have a motor that runs a fan, for example. How do you draw a motor? You might draw it with an M with a circle around it, and then you just put two lines. Okay, it's not actually necessary like to draw these two little extra things, just in the same way it's not really necessary to draw these little flags. Okay, sometimes people really like to draw them, so it's up to you. Okay, but I like these simpler symbols. Next up, here's figure B, and so these are the parts of a dry cell. So a dry cell is just another word for a battery, okay? So I think it's, I don't know, you can use either one of them, okay? And so inside the battery, so I'm just gonna not worry about this right here, okay? So don't worry about this. But there's usually a plus terminal, a minus terminal, okay? There's a container, there's like don't worry too much, but there's some sort of a chemical paste, okay? Uh, and there's a chemical reaction that causes the electrons to flow, okay, when you connect it with a wire, okay? So a dry cell changes chemical energy to electrical energy. Dry cells come in many different sizes and strengths, okay? So we for example, know that there's like uh, AA batteries. There's also AAA batteries that are the smaller ones. And then there's B, C, and D batteries as well. Okay, and they just get like bigger and bigger. So maybe I'll just write down AAA, because this would be in order of the size. Okay. Okay, let's keep going on. So look at the picture, then answer the question. So let's understand a little bit more about electric current. So anything that works with electricity is called an electrical device. We call some electrical devices appliances. Now, electricians call them loads, okay? So anything that converts energy from one thing into another, okay, that's called an appliance, or electricians will actually call them loads. Okay, let's name some of these things, okay? Just copy these down. So figure C shows some electrical devices. These are like super old because, as you know, these handouts are super old, but I really like them, so I like to keep them on file, okay? So how many of these can we name? We don't need to name all of them, okay? So let's just name a few of them. Okay, so go for it right now, name some of these aloud, and then copy these down. Okay, so for example, I see a radio, I see a fridge, I see a flashlight, and I also see a toaster, I also see a clock and a blender. Okay, how many other electrical devices can you name? You can probably name a whole bunch. Think of anything that takes a battery or anything that's plugged into a wall outlet. Okay, and so we could think of a computer, we could think of a cell phone, we could think of a microwave, blah, 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 blah. Okay, there's all sorts of electrical devices. Okay, let's learn a little bit about current electricity. Okay, so here what we have is a battery. This is a real live switch, and this is a light bulb. Okay, so this is a picture of it, but I think it's good for you just to see a picture, like a real live picture of it. Okay, so this is an open circuit. Okay, so let's just copy this down. Okay, this is an open switch. That means that this metal part is not making contact with this metal. Okay, so for example, if electrons were flowing, okay, it would start from the negative terminal, it would get through here, it would get to the end of this, but because the metal is not making contact with metal, the electricity stops. It cannot actually flow properly. Okay, so you don't need to copy this down. This is just so that you have an idea of what this looks like, but please do copy this down. Here's a picture of an open switch. Okay, it is open, it is not making contact metal with metal. Okay, so is this circuit complete or incomplete? Well, look at the light bulb, right? It's not shining brightly. That means that the circuit is incomplete. Please copy that down. If a circuit is incomplete, are the electrons moving? So yes or no, are the electrons moving? No. Okay, does the light bulb light up? No. Okay, so here are the notes. Okay, so I'm hoping that you can make these connections. Take a few moments, let this sink into your mind, okay, and you can so that you can really absorb the information and make these connections. Open switch means that the circuit is incomplete. If it's incomplete, it means electrons are not moving. If the electrons are not moving, then the device or the light bulb does not light up. Okay, take a few moments. Pause the video, please feel free. Okay, next up, let's see this other one. So here we have a picture of a battery. It is connected by a wire to this switch. Notice that this switch is down, right? This switch is down. This is a closed switch, so let's write that down. Okay, this is a closed switch. Okay, closed switch. This means that it is on. Okay, closed switch means on. Okay, please copy that down. Notice then that the light bulb is shining, and then what can happen is that the electrons can keep flowing through here and it gets reconnected to the other side. So it's actually forming a whole loop right here, okay? So let me just show you a picture of this like in real life, okay? So you have a battery that's connected, okay, to a light bulb and connected to a switch. Notice that the switch is now down and it's actually making contact. Let's just compare that with this. Notice that there was a gap right here. Okay, a gap means that the switch is open. No gap, meaning contact, okay, like the gate is closed. This is a closed circuit, which means that it's on. Okay, so is this circuit complete or incomplete? Well, it is complete because the switch is closed, okay? Are the electrons moving? Yes, they are. They're moving because the circuit is complete. It's forming one complete path. If the electrons are moving and it's complete, yes, the light bulb does light up. Okay, so electricity flows from minus to plus. So over here, they've taped the wire to the bottom of the battery. So we want to draw the arrows near the wires, the switch and the battery to show this path. Okay, so they kind of already have some arrows, but just to show you, okay, make them really clear, okay? So over here, it originates, the electricity flows from the negative terminal. It goes through the wire here. It actually passes through the switch because metal is making contact with metal. And because the gate is closed or the switch is closed, it makes contact with the wire down here and with this little the little gate right here. It goes down the wire here, goes in through here, makes contact with this light bulb. The light bulb has a bracket. The electrons keep flowing through. It goes through this filament, goes over this way as well, keeps going through the wire, and then it returns to the positive terminal. As it returns to the positive terminal, that chemical reaction that's producing more energy, it is flowing and it's actually creating one complete path. Okay, so what I want you to realize is that in this diagram here, it actually forms one complete circuit. Okay, there's a continuous flow that keeps going through and through and through. That is the reason why the light bulb is on. Okay, let's take a look over here. If we did the same drawing here, it would come out of the negative terminal, it would go to here, and then it would stop. Okay, we cannot complete the circuit. That's why this bulb is not shining brightly. Okay, hope that makes sense. Okay, we're going to fill in the blanks. Actually, what I want you to do is you can just practice. If you have the papers in front of you, please practice this, okay? If not, no worries. We're going to be doing this in the quizzes assignment, but if you want to kind of preview some of the questions, they're right here and you can kind of study for them, okay? Feel free to take pictures of this if you'd like, or if you would rather just do the online quizzes assignments, that's fine too. Okay. Now, this is just from the previous page. Okay, so this is from page 123. You don't have this on your paper, but let's just practice this, okay? So practice this on your own. Pause the video. You can look them up from your notes, okay, or you can just look at them on the video. And if you have the paper copy, just start identifying each of these items, okay? So pause the video and then come back to me. Okay, so I hope you were able to do some matching. Okay. If you didn't want to write all of these down, that's okay too, right? Because as long as you kind of just mentally go through and just associate each of these drawings with the name of the device. Okay. Let's just practice one more time drawing these things, and then after this, you'll be ready for your assignment. Okay, so one dry cell. Let's do this together. Okay, so one dry cell. Okay, that looks like this, right? One dry cell, positive and negative. Two dry cells connect together. So if there's two batteries, there has to be long, short, or I'm going to flip it around. Okay, here's the wire. Then we have short, long, short, long. Okay, sorry, I should be using a ruler, but it's annoying with this program, okay? A wire just looks like this. A light bulb looks like a cursive E, okay, and then just with a circle around it. A motor is M with a circle around it, and then you just want to show that the wires are connecting to it. Open switch, so think about an open gate. Okay, I just need to go like this. Closed switch. Okay, pause the video if I'm going too quickly. And then lastly, an appliance or resistance looks like this. Okay, just some squiggles connected to the wire. Okay, so I hope you were able to finish that off, okay? And then feel free again just to practice these on your own. You can either do them just verbally or you can just write them down as your answers, okay? And then that's going to be really good practice for the online quizzes assignment, okay? So feel free to review the lesson a little bit more, and then when you're finished reviewing, remember to sign in with your TDSB email account. And you can click on the globe right here on the PDF. That's the attached PDF. You can click right there, or you can sign into Google Classroom, and the online quizzes assignment is also posted there as well. Okay, sorry for the super long video, everyone, but I'm hoping that that was okay. I feel like it's probably good for me just to walk you through everything, just like we're in class. And since now I think most people have the papers, it's probably really good for us just to add the notes to the papers. Okay, if you don't have the papers, don't even worry about it. If you don't have toner for your printer and so on, okay, don't even worry about it, okay? So everyone, thank you so much for listening, and sorry for the long video. I'm going to try and keep it shorter for next time. Okay, everyone, take care, and remember to do that online quizzes assignment, okay? Thank you, bye-bye.